So we are now recording. My students, you are going to end up on test day turning in this completed. This is what you're doing. Okay? Tuesday and Wednesday. Okay? If you are not my student for algebra support, for algebra, today you're going to turn in your completed review. Headphones out of the use. Okay? So if you are in my class, you're going to have to turn this in completed, so you can write it down now. If you are not in my class for algebra, you are going to turn it in today, completed, filled out, what we did. Got it? Got it. So, for my students, this looks just like the test that they're going to have on systems of linear equations. The first question asks, tell whether the ordered pair is a solution to the system of negative 3x plus 2y equals negative 21 and negative x minus y equals negative 2. So for this problem, it's a guess and check problem. You're going to take 5 and negative 3 and plug them in. So, negative 3, oh, why is this not, the slate's not going to work? Negative 5 times negative 3 is going to give me negative 15, correct? 2 times negative 3 is going to give me negative 6. Negative 15 minus 6 is equal to negative 21. So it checks in that equation. In the other equation, negative x means I take the x that I'm given and I put a negative in front of it. Minus the value that I'm given for y is negative 3. Subtracting a negative is the same as adding a positive. Negative 5 plus 3 is negative 2. So that checks. So the answer is yes. So on your papers, you should show me that you were able to write this and plug this in. It will be easier to do this if you're writing while I'm actually doing. So yes, it is a solution. That's what we mean by solution. The next problem, you had problems like before in prior chapters, you may not have even realized it was a system of equations. Okay? The fun guys have a game rental. And they have a fee system that they use. They charge an annual fee of $5 plus $5.50 for each game rental. So I always say use magic boxes. Figure out what's your multiplication or division and what's your addition or subtraction. So Kaylee, tell me what's my multiplication or division here? What keeps happening over and over again? The 550. That's my multiplication. So I do the multiplication, then a variable. I'm going to use G for games. And they charge a $5 fee. That's fun, guys. The Game Bank is another company. They only charge how much per game? $2.50 per game. But they have a higher annual fee. I have to pay more money. I have to pay $17 to join them. Okay? In this case, we want to know when will the cost of games be the same here as here. There should be a G. We could say, well, one game here would be $5.50 plus 5 would be $10, right? And one game here would be $2.50 plus 17 is $19.50. That's not the same. Then we could try 2 games, right? Then we could try 3 games, correct? Then we could try 4 games. I could just try 2 games, 3 games, 6 games, and 4 games, because those are my choices. But then I have to do the problem 4 times. So I'm going to say, well, when are these equal to each other? And if I take 250 and subtract it from 550, I get $3, correct? And if I take 17 and I subtract 5, I get 12. And then when I divide both sides by 3, G is equal to what? 4. So it looks like 4 games. I could check that. I don't know if you have a calculator in front of you. I'm going to do this on the calculator. So if I have 4 games at $5.50 each, that's $22. Plus 5 is 27. That's what it sounds like. Over here, if I have $2.50 a game times 4 games, that's $10. Plus the $17 charge is 27. So that's why A is my correct answer. You should have the equations written on your paper. You should have the work for how to solve it. Okay? I will make it bigger. Then you can want to come sit up here. Okay. You have all that written down? Okay. So for the next problem, at the local pet store, zebra fish cost $2.10, and neon tetras cost $1.85 each. Whoops, that went way up too high. Okay. Marcia bought 13 fish for a total cost of $25.80. This, to me, is probably the most difficult problem of it. Okay? So I'm going to use Z for zebrafish, and I'm going to use N for neon tetras. If you remember, you probably don't, when we talked about these in class, I said sometimes you can think of, especially when there's money, one of these equations is going to be a quantity equation, like number of something, and one's going to be a value. Value is money. So a zebra fish costs how much? Okay, so for value, $2.10 for every zebrafish she buys, correct? And then how much does a neon tetra cost? So $1.85 for each neon tetra. And how much money did she spend? $25.80. Okay? Now, she bought 13 fish. So zebra plus neon. Okay. So here's the thing with this problem. I could solve it with a system. Correct? Even if I don't know how to do it, I know I probably could solve it with a system because that's a chapter. In order to solve it with a system, I either need to use substitution, get one of these variables by itself, or I need to do multiplication and like multiply everything by $2.10. Or there's option 3. Because really at the end of the day, I want you to just have a basic understanding of how math works. Okay? So anybody have an idea what option 3 is? Since it's multiple choice, guess and check. So let's see. Is 5, let's first see if we can cross anything out. Is 5 plus 8 13? Yes. Is 7 plus 6 13? Yes. Is 8 plus 5 13? And is 6 plus 7 13? So the first equation doesn't help us get rid of anything, does it? So now I'm going to use the second equation. And I'm going to plug in 5 for zebra and 8 for neon tetras and see if it works. See if it's $25.80. Okay? So I'm going to have a calculator out here. My first option is 5 zebras, and a zebra is $2.10 each, so that's $10.50 for zebras. Plus $1.85 times 8 for neon tetras is $14.80. $14.80 plus $10.50 is $25.30, and how much did she spend? So does option number 1 work? No. Let's try option number 2. Oh, I erased the equation. I don't want to do that. What was our equation? It was $2.10 for zebra fish. And how much for? $1.85 for neon tetras. So, 7 zebra fish cost $14.70. And 6 neon tetras costs $11.10. Did I just find my answer? Yeah. If you can't see the board and you want to move up closer, we have seats. Okay. Okay. So, and that's fine. We have a student here, I can't say names because we're video recording, that actually just tried like different combinations and adding stuff up. But you know what? If you get the right answer and you walk across the stage at graduation, who the heck cares? Right? I mean, and I mean that sincerely. I don't mean it kind of as like a joke. Like, we're trying, the whole goal of the class is trying to get a certain understanding of how numbers work. So if you are able to get an understanding that works a little differently than what we're doing here, that's fine. Okay? That's why I go over the guess and check. So for number 4, Elena and her husband Michael. Mark? Yeah. Sorry, I can't read. Okay. Elena and her husband Mark both drive to work. Elena's car has a current mileage of 9,000. So her car is at 9,000 miles. And she drives 18,000 more each year. So she drives $18,000 every year. 18,000 miles. And she already has, okay? And I'm going to change that Y to an M. Okay, that's Elena. For Mark, he currently has 60,000 miles. And he drives 7,000 miles a year. Okay? Will the mileage of the two cars ever be equal? Well, eventually, if they both keep their cars, right, she's going to catch up to him. She has fewer miles to start with, but she drives a lot more. So look at your answers. So, no, the equations have equal slopes. They don't even have equal slopes. Do the equations have equal slopes? The slope is the change every year. One is increasing by 7,000, one is increasing by 18,000. Okay? So the equations have different slopes. If they have different slopes, the lines are eventually going to intersect. Even though it's a big word problem, that's ultimately what they want you to get. If I have two lines with different slopes, the slopes are, at some point, the lines are going to intersect. Okay? So, that, if you remember when we did solving by graphing, when the equations had the same slope, they were parallel, they didn't intersect. These have different slopes, different changes. They're eventually going to intersect. Okay, next one. Tell whether 9,2 is a solution to this. So we're going to plug this in. 4 times 9 is what? It's 36. Plus 1 is 37. Is 37 greater than 2? Yes. So it is a solution. Okay? It is a solution. That's all. When I ask is it a solution, you're just plugging numbers into check. Okay. So for the next problem, okay, this one involves shading. I know we were having a very difficult time with shading in class. This is technically, for my students, this is not a chapter 6 problem. It's really a chapter 5 problem. It's just one line. But for my students, we didn't do this lesson in the first semester, so we're doing it in the second semester. So here's the nice thing about this. It's multiple choice. If you look, this line, the actual where the line is the same in every problem. You don't even have to figure out how to graph the line. Negative 8x plus 2y is greater than negative 6. They've graphed it for you. Since it is greater than but not equal to, it's a dashed line. So if you look, it's a little bit difficult to tell up here. If you look at yours, I believe A and D both have solid lines. Correct? A and D both solid lines. So it cannot be A, and it cannot be D. Okay? So this symbol is X and Y are greater. So there's two ways to figure out the shading. Greater is here. You would shade this side. But if you don't really get that, and the X and the Y confuse you, or the shading confuses you, I try to use the point 0, 0. But pick a point that is blatantly not on the line. Meaning 0, 0 here, and 0, 0 here, right? They're close to the line, but they're not on the line. You could pick any point. You could pick negative 4, 4. You could pick negative 10, 200. Why do you think I'm picking 0, 0? It's easy. And plug it in. If negative 8 times x, which is 0, what's negative 8 times 0? 0. And 2 times 0 is 0. And 0 plus 0 is
0.
Is 0 greater than negative 6? Yes. So guess what? It's a possible solution. Meaning you shade the side that it's on. Hence why this is the answer. Did you follow that? If you need to, you pick a point that is clearly not on the line. So for instance, let's say I picked point 10, 1. Is 10-1 clearly not on the line? Okay? And I plug that one in. Let's say I plug that one in. Let me change colors here. Negative 8 times 10 is what? Negative 8 times 10 is negative 8. 2 times 1 is 2. Negative 80 plus 2 is negative 78. Is negative 78 greater than negative 6? Is negative 78 greater than negative 6? No. So guess what? It's not a solution. Don't shade that side. Shade the other side. You pick, so again, you pick any number, any ordered pair clearly not on the line. The problem is if you pick something on the line, then you don't know which one it is, right? You plug it in. You see if it works. If it works, you shade that side of the equation. If it doesn't work, you shade the other. Okay? Here we have another problem. Okay? Tony has $18 to buy apples and bananas for a fruit salad. Apples cost $2 per pound and bananas cost $1 per pound. So let's think about this. Apples cost $2 and bananas cost $1. So, can he spend more than $18? Can he spend more than $18? No. So it has to be less than. Can he spend equal to $18? Yes. So first of all, looking at the graphs, are they all dashed lines or any of them solid lines? They're all solid? Because it's hard to see up here. Okay, so they're all solid. So we can't cross that out. This is the equation we wrote, correct? Is that same equation? Is this the same equation? Is B the same equation? What's wrong with B? It's greater than. Can he spend more than $18? So it can't be B. Is C a correct equation? Huh?
Yeah.
No. Less than. Is D a correct equation? No. So now my only possible choices are A and C. Think about it. A has the shading for the one side of the line. B has the shading higher up. Which one makes sense? You can't spend more than $18. So is there a bottom you can spend or a top you can spend? There's a top. Which one shows a top, basically? Do you understand what I'm saying about bottom and top?
Yeah.
I can spend up to that amount. Okay? Guys, sometimes you have things that have a bottom. Okay, the one that comes to my mind, I don't know if you do it, but I used to have in Florida, we have I'm sure you have them there, Secret Santas. But when you're buying a Secret Santa gift, typically they say like you need to spend between $5 and $10. Okay? They don't want you to get your Secret Santa like stuff that's $1, right? Or Lamborghini. So if we had a bottom limit, we must spend at least so much money. Okay? I was at Katie's last night. First time ever. Katie sent a picture. sure you've all been there. So I like this. Katie's Country Kitchen says, on Mondays and Wednesdays, if you gamble, okay, you can get a free meal. You gamble? No, not really. You have to get at least 100 points on your players card. Now, I don't know how you get 100 points on my card. That to me sounds like you have to bet $100 somehow. Okay? But again, that's a minimum. If I wanted my free meal at Katie's on Monday or Wednesday, I have to gamble a minimum of this amount. If I gamble and score 300 points, will they let me get free meals? No. I only get one free meal. I have to spend over 100. So I don't know if that helps or if that confused you more, but I'm trying to give you examples of when something would be graphed over the line, when there's a minimum threshold. In this problem, there's a maximum. Why do you think you can't spend more than $18 for fruit salad? Exactly, she said it perfectly. Because he has no more money. Okay? Or because he decided, you know what, $18 is enough money for these people for fruit salad. Right? You had to make fruit salad to like bring to like a potluck dinner. You might decide, I'm not spending any more on these people than $18. Okay? So that's number 7. And then we have number 8, solve by graphing. Okay? So you could do a few things. If you positively, absolutely cannot write equations, and you were like, you know what, when we have equations, I'm going to mess it up. Could you use guess and check on this problem? You could take the first thing of 4, -6, and plug them in and see if they work. And then you could see if they work in the second one. Okay? You could also graph by plugging in zeros. So if x is 0 on this one, y is -9, correct? Does this have a y-intercept of -9? Yeah. Does this have an intercept of -9? No. Does this have an intercept of -9? Yeah. This one? No. Oh, no. No. So look, I just crossed out 2 possible ones with just that. Okay? This will have an intercept of -9 for y, and for x, 3x equals -36, and x-intercept of -12. So let's look here. This line has an intercept of -9, right? Does it have an intercept of -12 of x-intercept? That should be over here, right? That's -9, -12. My point being, we figured out the correct answer by just solving the intercepts for one time. Could you have also done guess and check? 3 times 4 is 12 plus -24. Is 12 plus -24 -36? No. 3 times 4 is 12. 4 times 6 is 24. Is 12 plus 24 -36? No. -4. 3 times -4 is -12 plus 24. That doesn't work. -4 times 3 is -12. Plus 4 times 6 is -24, -12 plus -24 is -36. So if you're like Mrs. Falk, I just cannot solve I just can't graph. Can you still get this problem correct? Yeah. That's a beautiful thing. Right? I'm going to break this review into 2 videos so we can take like a 5-minute break, clear our brain for a minute, and then